So let's go ahead and do a kind of a brief introduction to acids and bases. So a couple of things. Whenever I have acids, same thing with bases. I can have like strong acids, weak acids, etc. These are the same thing as when we talk about strong electrolytes. And remember, a strong electrolyte reacts completely. Same thing. Hydrochloric acid is going to be a strong acid. It's going to react 100%. It's going to go in one direction. Weak electrolytes have an equilibrium. The same thing with weak acid. It has this equilibrium. So in fact, you can call weak acids weak electrolytes, strong acids strong electrolytes. Let's take a look at this reaction right here. This is a classic strong acid. This is hydrochloric acid. And what happens is whenever you have an acid, it donates an H+. So this H+ is going to go to water. In this case, water acts as a base. It's going to pick up an H+. So after a reaction occurs, now I'm going to have H3O. And it picks up a positive charge. So this water is a base. It picks up an H+. So basically, acids donate H+. Bases accept. Always keep in mind, acids and bases are opposites of each other. Now what happens is, once hydrochloric acid loses H+, remember this is H plus Cl negative, it's going to be left with just a chloride ion. So again, a couple of things. This is strong now because the arrow goes in one direction. This is 100%. So again, there's not going to be any hydrochloric acid left in solution. I'm just going to form H3O+, which is the hydronium ions. And that's the chloride. To measure how acidic or basic a solution is, you look at the concentration of hydronium ions. That's the key to that. So to continue with this, I want to take a look at conjugate acid-base pairs, and just for us to recognize it. Conjugate acid-base pairs are related by loss or gain of H+. So for instance, this is H2O and this is hydronium. This is related by the gain of H+. So water was a base here. The hydronium ion is going to be its conjugate SAC, conjugate acid. So these two are related. Was a base, picked up an H+, now it's its conjugate acid. Same thing, hydrochloric acid, it's an acid here. It's going to be a conjugate base here. So hydrochloric acid lost an H+, so that's going to be its conjugate base. Water picked up an H+, that's going to be its conjugate acid. So the conjugate acid is the one that gained an H+, the conjugate base is the one that lost an H+ from the reactants. Let's take a look at a classic weak acid. So this is going to be acetic acid. So when you have vinegar, it's acetic acid dissolved in water. And notice now when this reaction occurs, it's going to be in equilibrium. So water acts as a base again. And so acetic acid is going to donate its H+. This is basically the hydrogen ion plus acetate ion. It's going to donate an H+. So now water picks up a H+ again, so it forms hydronium ion. This lost an H+, so now I'm just with the acetate ion. It's right over here. Couple of things about this one. This was a base. Again, these are related by the gain of hydrogen. So this is going to be the conjugate acid. Acetate, and this is going to be related. Acetic acid is going to be related. This is the conjugate base. And so be able to recognize a conjugate acid versus a conjugate base. And one thing to notice that maybe only about maybe about 5% of it reacts. So again, maybe about 5% forms hydronium ions. The rest stays together in solution. So again, when something's weak, either a weak electrolyte or a weak acid, it only reacts just a little bit for that. So a couple of things. Water can act as both an acid as a base. Usually acts as a base, but sometimes it can act as an acid. So this is ammonia. So in this case, water is going to act as an acid. So it's going to donate to H+. And so a couple of things now. I always think of water as HOH. You can think of water as HOH. Now it lost an H+, so now it's going to be hydroxide left over. So this right here, now the water has lost an H+, it's just a hydroxide ion. NH3 is picked up in H+, so it forms the ammonium ion. And notice it's going to be a weak acid, so it's a very weak acid. So only like a few percent of it actually reacts. We got that equilibrium. So a couple of things. So this is the base. This is the acid. So I want you to be able to recognize a conjugate acid, conjugate base. So this is the acid. Now it lost an H+. Now it's going to be the conjugate base. This right here picked up an H+. It was a base here. That's going to be its conjugate acid. So be able to recognize how species are related by loss or gain of hydrogens to be a conjugate acid, conjugate base, etc.